Everyone loves superheroes. Some are born into their powers, some are super geniuses, and some are just ordinary people who receive their powers through some sort of freak accident. Spider-Man being an ordinary genius who happened to get his powers through a freak accident. Crazy, right? Anyway, Peter Parker was a high school student on a field trip with his school when he got bit by a radioactive spider. Which is terrifying, but we'll skim over that part for now. This spider bite resulted in becoming the superhero we all know as Spider-Man. It gave him some pretty cool powers, including super strength, super healing, the ability to crawl on walls, and a sixth sense we know as Spidey Sense, which allows him to sense danger before it's happened. Now, while all of those previously mentioned abilities would make a pretty good superhero on their own, Peter needed to figure out a way to navigate New York City and effectively fight off some bad guys. To do this, he came up with the idea to build web shooters that could shoot webs at the press of a button on his palm. We're going to start off today asking ourselves, is web slinging really a better mode of transportation than just running? If you noticed in the video, his pattern of swinging resembles that of a pendulum, so I use the equation t equals 2 pi times the square root of L over g. G being the force of gravity, which is 9.81 meters per second. We still need to figure out length and time. For this equation, I used length as the average height of a building in Manhattan, which is 142 meters, but I halved that to be 71 meters, as he never really started from the foreground. T in our equation represents the period of a pendulum swing, which is a left swing and a right swing. But because he's only going in one direction, that'll factor into our equation later on. You then need to plug in all the variables and get 2 pi times the square root of 71 over 9.81 equals 16.9 seconds. But because he's only going in one direction again, I halved that and got 8.45 seconds. Now, of course, to answer our question from earlier, we need to look at another time to compare our previous time to. And to do this, I looked at a man who I'm pretty sure is in fact superhuman, Usain Bolt. His record speed is 28 miles per hour, and I converted that to meters per second, which is 12.5 meters per second. The equation I used was speed equals distance over time. Our variables being speed equaling 12.5 meters per second, the distance being 142 meters from our previous equation, and we need to figure out time now. Time would be distance over speed. Which leaves us with the answer time equaling 11.36 seconds. Which of course leads us to the answer that web slinging is in fact superior, and that's not even counting in the fact that he can now avoid foot traffic and leap over buildings, which would significantly decrease time in getting to a crime scene. Which then leads us to our second point. Elastic collisions. There is a panel in one of my favorite comics in which Peter runs straight into a building, and I decided to figure out what the equation for that would be. Our variables being the mass of the first object, which would be Peter, and average male weight is 170 pounds, so I converted that to kilograms, which is 77 kilograms, and then I used 20 meters per second as both initial and final because he's bouncing off a building. The building isn't going to accelerate much, so Peter would repel with the same force he came in with. The mass of the second object was a 28-floor building, which I worked out to be 5,600 tons, which equaled 5,080,235 kilograms. And then its initial velocity would be 0, and we're trying to find out the building's final velocity, because it's going to accelerate a little, just not a lot. Plugging this into the equation will leave you with 77 times 20 plus the mass of the second object times its initial velocity, which will cancel out later, equaling 77 times 20 plus the mass of the second object times its final velocity, which we are trying to work out. This will leave you with 1,540 equaling 5,081,775 times the final velocity of the second object. You then have to divide that number by 1,540 and you get 0.003031 meters per second. So it's going to accelerate, just not a lot, as previously mentioned.
I hate this song!
When I first watched this scene, I thought it was pretty cool because I noticed that the towers Electro was using to play music resembled Tesla coils. So that's what I'm going to talk about lastly. Tesla coils consist of two primary parts, two coils, each with their own capacitor, a spark gap, and a power source, as well as a transformer. First, a power source is hooked up to the primary coil. The energy from this power source will be soaked up by the primary coil's capacitor. Eventually, that capacitor will reach a point causing the current to flow out into the coil. Once there is absolutely no energy left in the first capacitor, an inductor will send the voltage into the spark gap. That voltage will then move into the secondary coil and energy will move back and forth between those two places. The top load of the capacitor will then concentrate that energy and let it flow out. We now have to look at how Electro made sound with those coils. We know that sound is caused by vibrations in the air, and the higher the frequency, the higher the pitch. The noise from the Tesla coils works very similarly. Tesla coils make hundreds of sparks per second, which push the air around them and result in sound. All you have to do is change the frequency of the sparks, and you get the noise that hits your ear like that of a music note. That is how Electro managed to make the Tesla coils play the tune of Itsy Bitsy Spider in the final scene. That is all for the physics of Spider-Man. My name is Lucy, and this was my final physics project. Thank you for watching.